Hello and welcome to this video. In this video, I'm going to talk about the important topic in the Kubernetes. That's the CPU limit. Do you think that in the container can only see the CPU limit that we assign to it? No, it's not true. It can see the whole CPU. Let's check it in practice. Now I'm running in the Minikube. Let's describe node to see that how much CPU do I have here. That's my pod. Let's see here. Okay, here I have 6 CPU in total for my node that's running the Minikube. But let's going to create a one pod. Now I assign the pod that's called limited pod, and there's the CPU request and the limit set to 1. And here I run the command that's going to copy from the 0 to null. That's actually do nothing, but it's going to get all CPU that the pod can. And I'm using the Alpine image. Let's going to let's going to deploy this one. kubectl get pod demo. Okay, now it's running. Now I'm going to the pod. Okay, let's see how much CPU can this pod see. For example, see that we're running some application and that's going to use the CPU, but let's see what that application see. Okay, we can use the top command, for example. Here we can see that, okay, that is the one that's the process that's use a lot of the CPU. That's 17%. Now I assign the one CPU to this container. It means that, okay, and it said 80% idle. Let's see what does it mean. Here I can see that 1 divided to 6, it means that near to 17. So it means the one CPU out of the 6. And here we can see that, yeah, when we minus them, we can see that, okay, 81% idle. But it's completely wrong. But why this thing matter for us? Actually, it's so important for the programmers and developers that's going to develop the application. If they don't consider these things, maybe some catastrophic things happen. For example, consider the application that's going to look up the number of the CPU on the system and decide how many worker threads they should run. So, actually it doesn't matter in my computer, in my local machine, when I have set the one CPU, but in total I have 6. But consider in the real production environment. For example, we have a 64 CPU. So actually the application going see that, okay, we have 64 CPU, so it's going to create a 64 thread for us. Actually, we know that the CPU kinda is not matter, but consider it's going to create a 64 threads for you. So now it's going to spin up the 2-minute threads, so all competing for the limited CPU time. So each thread require additional memory, so it's causing the memory usage going to extremely high in this scenario. But let's see in the pod what we can see here. Now we are in the Alpine image, so I want to check with the Python. Let's first install Python 3. Oh, apk add, and I want to check if we use the real application, how it see the CPU. I'm going to run the Python. Okay, import multiprocessing, and we can do multiprocessing dot CPU count. Here we can see 6. So if our program, like this Python application, said, okay, let's check the count of the multiprocessor CPU count and create these threads, so it's going to happen something bad. But how we can fix that? Actually, there is a two solution. One of them is we can do it with this image. Let's exit from this one. If we go to the C group, ls system, file system, C group. C group is the control group. So in the C group, we can see the allocation of the CPU resources, such as the CPU, memory, I/O, among the others. So if it's ls this one, we can see lots of things about the memory, about the CPU, about these things. But the interesting part here, we can cat the CPU.max. So actually CPU.max is going to show the limit CPU that we can use. For example, here it shows that during this period we can, that's millicore second, during this period we can use 1 core CPU. That actually it's a quota for the during this period. So if I set 2, for example, it's this one should be changed to 2. I can test it quick here. For example, I'm going to delete this fault first, then I'm going to change the limit to 2 to see that that file system should be changed. Let's see, because it's going to kill the processes and it's maybe take a little time. Okay, now we're going to change this CPU request to 2. Now if we back here and apply, then if we execute to here, cat to sys file system in the C group CPU.max. Okay, now we can see 2. It means that in this millicore second we can use 2 core CPU. It means that 2 times of this period. So if you want to get the limited CPU core, so you need to get this file. And the other solution, actually you can use downward API. Let me bring it here. Yeah, in the downward API we can set in the container to see some pod information like metadata, name. Also we can see the node name, we can see host IP, pod IP, and in the resources we can see limit of the CPU, request, memory, and the other stuff. So it's important, if you want to use it, you can check this documentation in the Kubernetes documentation, downward API, and check it. So thank you so much for you guys to be watching this video.